My name is Bobby Mitra. I co-lead the NEET program at MIT with Ed Crawley, a founding faculty co-director, and Mark Bartha, the faculty co-director. In fact, Mark is in the audience right now. He is back from NSF. He delivered the first bioeconomy distinguished lecture on a tale of two strands. And, I'm sure he will add and chime in. Um, Peko Jose was the founding faculty co-director with Ed. She is now the associate dean of engineering, so doesn't have much time for NEET, but is a great supporter. So I got inspired by Emanuela's opening. So John, it's all UCL fault that I'm going to take 2 minutes more than my allotted time. So I'm going back to the summer of 2016. I was sitting in Peko's office in Building 3 at MIT, being interviewed by Peko and Ed. Ed was in Moscow. He was just completing a 5-year assignment as the founding president of Skoltech, new university started with MIT and Moscow, government of Russia. And, Ed asked me, so what will you do in NEET in this role? And I'd been at MIT before. I'd asked a lot of people before the interview. Nobody had heard about NEET. So my question back to Ed and Peko was that why is MIT tinkering with its core brand, undergraduate engineering education, right? And the response was very interesting. It was more emotional than logical. There were two things that came through. One was they said that faculty at MIT have been feeling for a while that we need to innovate systemically across the board in terms of engineering and undergraduate education. Now, everyone teaching is constantly innovating. They're bringing in new material from their research, consulting, and what's happening in the world. But across the board, and Mark might know this better, I think the last time we introduced a new class, a new subject into the core curriculum was modern biology, maybe 20 or 30 years ago. It hasn't changed since then, right? So our mission to do this hasn't really changed. Our mission for NEET is to reimagine how our students learn, to better prepare them to address major societal needs and challenges of the 21st century. And that's the MIT mission. That's very much the NEET mission. And also to enhance our reputation as a worldwide educational leader. I think this is something that we have not done as well as we could have in terms of contribution. There are 4 guiding principles for the NEET project. The first one is that we are offering interdisciplinary programs called threads, which are centered on what are the new machines and systems for the future. The second one is on ways of thinking, which includes creative thinking, critical thinking, systems thinking, and other speakers have talked about this. The third is on project-oriented learning, project-centric learning. And the fourth, I think the most difficult, is how do we harness digital learning more effectively for our students? Fewer and fewer of them are buying textbooks. I think fewer and fewer of them are showing up for class, but they're obviously prospering. They're using the digital resource in a way that we need to learn better. So Ed's an aeroastro professor. This is our favorite slide, new and old. The old machine is the 50-year-old jumbo jet that was retired last year. The new machine is a quadcopter. Even today, a lot of the curricula in aeroastro is still focused on designing, building, manufacturing the old machine. And the new machine at best is 1 or 2 or 3 classes in an entire curriculum. So the neat ways of thinking. So these are 12 ways of thinking. They are not new. The collection is our way of defining it. And just to add to this, our students said that, so MIT students take 8 humanities classes out of about 32 in 4 years, right? So they have enough options to take humanities, arts, and social sciences classes. They said to us, we do not want to sit in yet more classes to learn about creative thinking or critical thinking, right? So we want to engage in interactively with short interactive modules that are pertinent to the context of the domain. So I really want to learn about the ethics of self-driving cars if I'm in autonomous machines, or the ethics of genetically engineered babies if I'm in living machines, and not ethics in abstraction. The other thing we did from a sustainability perspective, so these modules and development of these modules is not led by the engineers. Notwithstanding, engineers seem to think that we have the answers to everything. Alex Byrne, who chairs the Department of Linguistics and Philosophy, leads a team that's developing modules on ethics. Jen Light, who chairs the Science, Technology, and Society program in our School of Humanities and Social Sciences, is leading a charge on critical thinking. And Les Norford from the School of Architecture and Planning is leading creation of creative thinking. So, what was the original pilot? The conception of the pilot. The conception was that, so on the left side, you have the column which shows a degree from a department, on the right side is a degree from another department. NEET is really, the way we see it, it's an armature which binds the two programs, binds two disciplines through projects. So a student going through a NEET program would focus on new machines, on cross-departmental approaches, application-oriented and interdisciplinary, and come out with a degree in her major and a certificate in a NEET thread. I'll come to what a NEET thread is in my next slide, but we've been struggling with this for a while, that what is it that an MIT student gets out of NEET that she or he would not get out of MIT, given the excitement and the availability of things to do at MIT. And I think what we're understanding from the students, it's been about 3.5 years that the pilot program started, is that they want to join a community of other students from other programs and disciplines and majors, work in teams, and explore their passion. So the five broad domains that we have started to offer programs in: autonomy and robotics, materials of the future, drug development, pandemic, designing technology for the public good, or what's commonly called smart cities, and the fifth one is climate change, green energy production, and so on. The other thing that they are acquiring is what we call, again, the NEAT way of thinking, and this is being done explicitly. This is not being done as part. It is part of classes, but it is also being taught explicitly. So along the way, 3+ years, the five threads that we've created, we've launched several initiatives in the ways of thinking. They're embedded within projects and seminars. They're in standalone subjects. There's educational research. There are different pilots going on to learn from. We have started to get more engaged with the International Engineering Education Committee and our peer community. I won't spend time on the global report. That's what brought us together, authored by Ruth Graham. MIT is also a co-sponsor of CEDA. Ruth talked about that in her keynote. We've presented papers at the last 3 ASW national conferences. And again, it's part of our effort to engage with the community, learn, and share. We've also created a strong program evaluation effort with experts from MIT Open Learning, because not just the dean, but we ourselves want to know how we are doing and what we are not doing and what we can do differently. So the meat of it. These are the five threads that we are offering. They're called autonomous machines, living machines, advanced materials machines, renewable energy machines. You can see the pattern there, but we have to break the pattern. So digital cities does not have a machine stack to it. And that's a pilot within a pilot that is led by the School of Architecture and Planning with the Department of Electrical Engineering and Computer Science. So it is not an engineering-led program. What you see at the bottom is the majors that typically apply for this. So Aeroastro, Mechie, and Electrical and Computer Science. Students make up autonomous machines. Living machines comes from bioengineering majors, Mechie majors, ECS, chemical engineering, and so on. And renewable energy and digital cities now taking majors from across MIT. Engineering, sciences, humanities, arts, and social sciences, Sloan School of Management, and architecture and planning. Each thread is led by a professor or faculty with a team of faculty. The NEAT thread instructors are the full-time people who are focused on delivering the project aspect, and they bridge between the faculty and the students and are available in the labs and as a constant resource for tech support, for thinking through things. There are now, I think, over 20 faculty overall involved with this program across 9 departments. And those 9 departments form the faculty steering committee that guides us in our endeavors. Just a quick example of what we mean by a project framework and armature. So this is the autonomous machines pilot that was launched in fall of 17. Starting from the graphic on the extreme left, in their sophomore fall, students do a hands-on project seminar, 3 to 6 units on how to program a smart car, learning how to use Arduinos, the excitement of doing something. In spring of sophomore year, they start with sheet aluminum and they end up with a robot that sings and dances and is tied to a theme. This is derived from an iconic MIT class called 2007. In the junior fall, they do a hands-on seminar where they learn how to program a drone. We have a new facility which is 50 feet high. It's fascinating to go there. And in their junior spring, they are given this race car, and the focus is on programming. In sophomore year, it was on building mechanically and robots. In junior spring, the focus is on how do you program this thing to become a self-driven vehicle. And the final exam is a competition where they chase around these vehicles in MIT basement. There are pizza, T-shirts, and there's a lot of fun and games. And finally, in the senior year, uh, they and a lot of this we've learned. For example, Alberg allows its students to choose their projects, and we are finding that to be very motivating for the students. So in the senior year, these students from aeroastro, mechanical engineering, electrical, and computer science, in fall they do a seminar where they define the project they want to work on in spring. They interact with faculty, they interact with our founding co-sponsors, General Motors and Boeing, with other researchers. And then in spring, 1684 Advanced Autonomous Robotic Systems, they operate like a small startup company as a group. And for example, the first one, they did a simulation of an inspection drone for bridges and other concrete structures. And now the faculty are working on the next time it's going to be offered, which is this coming spring. Given the pandemic, it will be different, but it will still be part of this. So the results, exciting and also a little bit frightening. So we currently have 187 sophomores, juniors, and seniors. This forms the fourth largest undergraduate academic cohort across MIT. Here's a short quiz for the audience. Please use the chat. The largest cohort at MIT is computer science and electrical engineering. The second largest grouping is mechanical engineering. What do you think is the third largest undergraduate academic cohort? They may or may not be a prize. That depends on John, Annette, and Rob, the co-conveners of the symposium. But please send in your thoughts on what is the third largest. We are the fourth largest. 64% are women. In contrast, MIT has about 47, 48% women in its undergraduate population. 28% are underrepresented minorities. It's about 21 to 22% at MIT. There are 25 majors represented across MIT in these 5 threads. And this last cohort that started this fall, over half the students, the sophomores, are from electrical engineering and computer science. And that's interesting. It hasn't ever crossed more than 20 to 25%. So the data is good, great. It's pointing us in the right direction. We don't quite know why it's happening, and part of the process is to understand that. It is starting to gain more and more traction with the students. This year, about 29% who signed up, and it's completely voluntary. They decide whether to sign up or not. Heard about NEET from current NEET students. We do a lot of advertising. We have open houses, pizza, T-shirts, research labs, small classes, walk around the corridor inviting students to join NEET. But it was interesting that hearing from current NEET students was the topmost. And students are drawn to 3 things: the NEET community, the interdisciplinary project nature and the way of thinking, and the career potential. I think it's, well, I'm not sure how much this will add to their career potential, but students, that's what the students feel. They like adding credentials this generation. But what was interesting to us was community. We did not start this program with any thought about building a community. And the first time we interviewed the founding cohort, which was midway through spring of 2018, we heard community, community, community. And then when we asked them, they said, the fact that I'm in Mechie, you're in Aeroastro, she's in electrical engineering and computer science, we come together once a week in a seminar. We listen to companies, we listen to researchers, we listen to problems that the world is facing, which involves all of us. They find that very interesting. This year, we have launched another pilot, a first-year discovery class to start to get first-year students interested in different things happening at MIT. It's called Discover the Magic of the Neat Ways of Thinking. There are 61 enrolled, 58 are continuing with it, which is great. And there's a lot of interest in taking that forward. So I'm proud to announce that the first cohort graduated from MIT this spring. There were 26 students, 18 in autonomous machines, 8 in living machines. Between them, they've created 6 startups. 9 have taken jobs in industry, like Ronit Langer, she's at Thales Analytics. Claire Trevick, autonomous machines, started up Aura Blue. Hector Castillo started up one called Flow with other machines. He's also doing his PhD in robotics. And Alexa in living machines is doing her PhD in systems biology. What is interesting is that 7 of them are pursuing an MEng, which is a 1-year program at MIT. And we think this is because the future is uncertain, the job market is uncertain, so they want to hedge their bets, gain additional certification, gain depth in an area, and then look at graduate school or the job market starting next fall. So, very briefly, I can see the clock ticking down behind John's head. So there were 4 major challenges that we observed through these 3 years. The first was that the course load that NEET was requiring them to do was just too heavy and too much and much more than what they were required to do in their major. So on average, we were asking them to do 3 12-unit 4-credit project classes beyond what they were doing in their majors, just not sustainable. Okay. And part of this was, we started off, let 1,000 flowers bloom, let it first get going, let's see what works, and then start to look at it. The second was that conceptually, we structured this as a project in sophomore year, project in junior year, project in senior year, and then of course discovered that it was creating a rigidity that was not part of the plan. So a student who went off to do an internship for a semester and couldn't do one of the projects was then not, it wasn't possible for her to continue in NEET because she'd missed a project, which didn't make sense. The third was, and we all know this, I'm speaking, preaching to the choir, building and sustaining project-based courses requires resources, thinking, it's complicated. And the fourth challenge was we are a lean and hopefully not mean group. We're a small team. We don't have any faculty of our own, so we rely on the departments and work with them. So we have access to limited resources. Sounds a bit of an oxymoron at MIT, but that's neat. We're a scrappy group trying to get ahead. So starting September, based on feedback, we redesigned the program, announced the new requirements in April of this year. Completely fortuitously, we all pivoted to remote or emergency teaching mid-March. The fact that we had announced a revised program provided more options to our students. Again, didn't plan for it, but it worked out really well. So there are 4 things happening here. One is that now on average, a student would take at the most 1 or 1.5 project classes beyond what they are taking in their major. Number 2, we expanded to look at what are the students doing and what is it that we can bring in to see. Remember that the goal here is to help them find their passion, dive into it and explore it. So there was a student who started up a company in autonomy and robotics in his junior year. He's the CTO for the company. He couldn't do a project. So when the faculty looked at what he had done, they came to the conclusion that he had probably done much more than he would have done in an on-campus project. So now we recognize things like starting up a company, being engaged in it. It has to be appropriate. It goes through faculty review, doing an internship. We recognize things outside the traditional credit unit granting process as swapping out as part of their progression through NEET. Faculty overload. It was terrific. Faculty jumped in and they carried the flag, they carried the load, but it's not fair to have them do that forever after. So we are working with department heads increasingly for faculty involved in NEET to get teaching credit for their requirements in the department. And another thing we did was, any student joining a program, all of you know this, wants to know, what am I expected to do? How is it different or more than what I'm doing right now? And how heavy is the program? So now on the website, we call the roadmap. So if I'm majoring in mechanical engineering and I'm interested in the advanced materials machines thread, I can go to the website. I can look at, this is the requirements for materials machines. This is what I need to do in my major. Here's where the overlap is. And then I can go and have an intelligent conversation to say, what can we do differently? So that's been a huge change. This is just a bit of a digression, but kind of brought this in listening to a lot of things that I've been hearing. So, who is the engineer of the future? And I think what we are seeing through NEET is that an engineer of the future is a generalist who learns the fundamentals, who uses general purpose tools, calculus, computational tools, physical simulation tools, whether it's MATLAB or ANSYS or, excuse me, or COMSOL or open source tools like Cantera or OpenSim, and specializes in a domain which is broad enough. So that's what we're starting to see. I mean, we all know that I can't work on a car anymore. I can't tune a car. It's a proprietary system. You can't do. You could do something 20 years ago. It's moving more and more to that kind of situation. The tools that are being created are even more complicated. So I think the challenge we are facing as a community is how do we help our students learn the tools, apply them, and build intuition about which tool to use when to get the best results out. So next steps for NEET, and this is my, I think more or less my last slide, is so we now, after 3.5 years, we're transitioning to a steady state model. Four things that we are focusing on. The first one is we've started the process of attracting resources from outside MIT and engaging more sort of formally with industry. We are working with the biological engineering and chemical engineering departments, for example, to raise resources for a combined biomaker space along with the living machines thread. We recently did a joint seminar with biological engineering, our industrial liaison partners program on humanizing drug development. We're consolidating the existing threads. There was an exciting opportunity for a thread called nano machines. I need not say more about that, but we put that on hold because we first want to consolidate what we have. We strengthened internal evaluation and deferred. We were planning a major international review next summer. Given the pandemic and the change, we deferred that by a year. That's what our faculty committee recommended. And finally, we're aligning more closely with departments. And we have the advantage that Rick Miller, founding president of Olin and now president emeritus, is the Hunsaker visiting professor at MIT for a year. So we're working with him to think through what we can do for the future. So, what have we learned in the last 3.5 years? I kind of anticipated John's question. I think the first thing, and I'm hearing this, is you have to have a bold vision. It has to be something beyond tinkering around with, oh, I'll teach thermodynamics in third year instead of second year, or do something else. It has to be something beyond this. The team is very important. In academia, typically we say A, B, and C, go off and do NEET, or go off and do tracks, or go off and do IEP, or something else. The team that we started off with, and with Mark joining us, we're even more strengthened, as two people who started up universities, has people who worked in the corporate world, have people who headed departments at MIT and know MIT very well. Mark chairs the student life committee, so he has a strong network into the student community. So it's a very complementary team in terms of skills and resources, and we all understand MIT well. Stakeholders. So from the get-go, even before we knew what NEET was, we started engaging. I interviewed over 40 senior managers in industry to ask them what would they want a NEET graduating student to have in terms of critical thinking, system thinking, creative thinking, and so on, right? Other stakeholders too. Piloting. We learned that the word experiment is anathema. People are really worried when you say you're experimenting in education. But piloting means you seem to know what you're doing, you learn from it, you move on, you keep improving. And finally, I think most important, thinking and acting like a startup. So we are sort of like an incubator, engine, skunk works, catalyst, I don't know what the right word is. But I think that has allowed us to move ahead a lot faster and in the right way, as opposed to our traditional academic curriculum committee method. So thank you very much. That's the MIT Henge, the Infinite Corridor. Once the pandemic ends, and if any of you come to our campus, please let me know. We'll walk you down the Infinite. Thank you.
Thank you, Ravi. So quick questions. Annette, do you have any comparative analysis of NEET compared to other students?
So the next question is, do we have any comparative analysis of NEET versus other MIT students?
Yep.
No. But what we have is we've been surveying the students through anonymous surveys, through focus groups. I meet a lot of, face-to-face We want to know why they've come into NEET, what they like about NEET, and what they don't like about NEET. So that data has helped us to reshape NEET and make it more relevant. This year, we have launched a formal programmatic evaluation with an expert from outside NEET. So we're expecting to get that data by the end of summer next year. And that data will go into looking at what MIT students are doing, what NEET students are doing, what's the difference. But I suspect it's going to be very difficult to come to quantitative answers in the short term,
Yeah.
because NEET students feel that this will give an advantage to their careers. I don't think so. I think the fact of what they're doing at MIT is going to give an advantage to their careers, right? So there's a subjectivity there too. But there's certainly an excitement with the NEET students. The demographics, percentage of women, underrepresented minorities, is clearly saying that there's a bunch of students coming together, about 200 of them every year, who want to do something. So now we're trying to figure that out better.
Excellent. Thank you very much.